This is going to go in your math notebook. And we have a graph here for this function. F of x equals 2x plus 5. Without even anything else, what do we know about this function? Just looking at the function. What are some? It's linear. What else do we know? Slopes 2? Y-intercepts 5, right? So here's that slope of 2. Here's that y-intercept of 5. Okay, so you and your partner, how are your values going to change as you go from 1 to 2 or 19 to 20? How's it changing? That's what you're going to answer first. Problem number 2. This is where you're going to make sense of, in general, between any 2 points. So let me explain this part before you work on it. What this says is, I can always do second point minus first point, right? Right here we got 7 minus 5 is 2. Right here we got 9 minus 7 is 2, and so on. Second point minus first point. Everybody following that? Yeah. So the second point always has one more input. That's all this says. See how it says x plus 1 here instead of x? Yeah. That just means the next one. Everybody seeing the next one here? Yeah. 2x plus 5, but it's x plus 1 because it's the next one, minus the original one. 2x plus 5 is just our original one. Right? So let's say x were 1. The next one should be 1 plus 1 or 2. If x were 3, the next one should be 3 plus 1 is 4. It's just giving us first point, next point. Okay? And you're going to see what happens with that expression. Then you are going to scale that up after doing problems 1 and 2. Instead of the next one, you're going to do 4 ahead, an increase of 4 input. So that'd be like how it changed from 0 to 4 or 10 to 14 and so on. And you're going to try the same thing with a similar expression. So if it's 4 more instead of x plus 1, what's going to go here? It even gives x plus 4. Okay? It's even given to you. So it's from our function. It's from our function. Okay, so if you do the first one, it'll model it as the next one. Then you'll jump to the 4 ahead after. So if you do 2, 3 is the same thing. You're just going 4 more instead of 1 more. Let's go. So checking this out, as I go up one more thing, my output always changes by how much? From 1 to 2, 19 to 20, doesn't matter, always changes by what? 2. Where's that in my function?
2x.
Yeah, it's my slope, plus 2, plus 2, plus 2. That common difference of 2 is happening over and over. It doesn't matter what my inputs are. The next one is always 2 more. Everybody good with that?
Yeah.
Okay, and then if you look at this expression, which says the next one, right? If we were to simplify this, we would get 2x plus 2 plus 5 minus 2x minus 5. Look what happens with the 2x's and the 5. What's left? 2. It works in the expression as well, right? This expression saying the next one will always be 2 more. And does this match? Yeah, it matches. We already had 2. Everybody good on that? Yeah. Okay, so next it's asking, how do the values change if we increase by 4? So if I started at 5, and after 4, I get to 13, how much did that go up by? 8. Okay, let's do another one. Let's start at 2. So 2 is at 7. 4 more is at 6. No. 1, 7. 4 more is at 5. It's 5, 15. So from 7 to 15, I went up how many? 8. So it looks like as I increase my input by 4, I'm going up by 8, which makes sense. It's 2 for 1, right? So 4 for 8. Now let's write the expression and check it. The same expression as here. The difference is going to be this.
Can we just multiply everything by 4?
Well, I'm going to do x plus 4. That means 4 past my x value, my input. Right? This is just saying my 4 after whatever one I'm starting with. If I have 2x plus 5, I'm starting with one of them. Right? This plus 4 right here says 4 after that. So what should the result of this be? 8. It should show a difference of 8. So let's check that out. I'm going to distribute 2x plus 8 plus 10 minus 2x minus 5. Okay, I didn't do something right here. What did I do wrong? Something's not right. That's good. I did this last hour and it worked out fine. What did I write in wrong, guys? 2x plus 5 Minus 2x minus 5.
Oh, it's the plus 10 by
Oh, I distributed my 2 to that 5 that's not there. Who cares? Do you guys see how I was like, something's not right? There we go. I can't, this 2 just gets distributed here. All right, we're good. So, my 2x's cancel. My 5's cancel. Look what I'm left with. 8. And that makes sense. If I change 4, 2 each time, that's 8 total. So you can look at different intervals. So you could also say, let's say I had to change it by 5. Then 5 away. 5 away is always going to be plus what? 10. Let's say I wanted to go 20 away. 20 away is always going to be plus what? 40, and so on. And the reason I'm doing this repeated addition is because a line has a slope. Plus 2, plus 2, plus 2 for each one. Yeah, if it was 3x, it changed, right? Yep, that's because it's 2. Everybody good with that? All right. Keep these notes handy for when you get homework. So if you think we started with the line here, what do you think's coming next? Exponential. So we're gonna keep the same idea going. We're gonna look at an exponential function next. I've got some notes I'm gonna hand out for this because I think it's nice to have notes for the table. That's coming out right now. Here's our function. Grant g of x equals 3 to the x test. So what does that mean? What's happening over and over? Multiplying by 3. Remember in the linear we were adding over and over? There's a difference, right? So, how does this change each time we increase by 1?
It multiplies it by 2.
It triples, right? We established it right here with our function. How do you spell triples?
T-R-I-P-L-E-S.
No.
T-I-R-L-E-P-S.
I wanted to put 2 P's there, kind of. Here's a fun one. Here's a fun throwback to a couple days ago. If it's tripling, what's the percent increase?
3.0. 1.3. 3.0. 4.0.
Wait.
I have not heard the right answer yet.
Oh, 7. 0.7. 2. 1.30.
200% increase is tripling.
How? Minus.
I'd love to tell you how. So,
700%.
hey, Bob, there's a class on the other side of that wall. Yeah. Walls divide things. Okay, so let's talk about why a tripling is 200% increase. So tripling, we multiply by what? 3. And if our factor is 300%, 100% of that is how much change? 100% is 0 change.
That does not make sense.
100% of something is just that thing.
Yeah.
So if I'm multiplying by 3, 1 of that 3 is no change.
Oh, I understand now.
1 of the 3 is no change. So 200% of the 300% is the increase.
But in your calculator, you would still multiply by 3.
Yeah, that's not what I'm saying. I'm saying
You're not all
if I multiply by 3, that is a 200% increase. Just like if you want a 100% increase, what do you multiply by? Don't say 100% because that's no change. 2. Yep. You multiply by 2 for 200%. 100% is no change. That's all you need to know for all those. But I thought that
So you
was...
still do 300% in your calculator?
You multiply by 300%, but that's 200% increase.
So you multiply it by 3
Yeah.
in your calculator?
Yeah, it is 3, yep. So, let's choose 2 new input values to see if it's true. So let's go to 9. We'll do 9 and 10. So 6, 5, 6, 1 times 3. Is it working? Okay, and then times 3.
59,000.
Okay, so to the x is going to be 3 to the x. And one more after 3 to the x is going to be 3 to the x plus 1. Okay, yeah, Ellie.
So it says like 3 to the x, but you're not actually doing 3 times 3 and 4 times 3.
What is it?
So everybody go with the 3 to the x being any point, and then 3 to the x plus 1 is just the next point, increase of 1. Again, so let's say x was 5. 3 to the 5th. The next one would be 3 to the 5 plus 1, which is 3 to the 6th. It's always the next one. Let's say we want to start with 3 to the 10th. 3 to the x is 3 to the 10th. The next one would be 3 to the 10th plus 1, which is 3 to the 11. One more. We're adding 1. Everybody seeing that the next point is 1 more? No?
Yes.
This is our function. Everybody sees that the 3 to the x and then the 3 to the x point plus 1 just means this point and then the next point? Okay. So we complete this table. Now let's see if this still works. The bigger one, right? Like up here we can do 81 divided by 27 to get 3. We can do any of these. This divided by this to get 3, any of them work. So in theory, the next one divided by the first one should give me 3. So let's try it out. 3 to the x plus 1 divided by 3 to the x. An exponent of x cancels. We're left with 3 to the first, or 3. It does work out with the expression still. The difference is when we looked at the line, it was a common difference. Plus 2, plus 2, plus 2, plus 2. This is a factor of 3, 3 times bigger. Right? That's how the exponential works differently. So you better believe if last time we did a jump, not just the next one, we're going to look at a jump again.
Wait, what does it mean? Wait, why do we do the 3x divided by 3x?
It's just saying the next point divided by the previous point should always give us a factor of 3.
Okay.
Yeah. So we're gonna go next now. Now we're gonna look of a jump of 3. From 1 to 4 per se. Okay? So let's do this together. So input of 1, 3 to the 1 equaled what? 3. Okay? And input of 4, 3 to the 4th equaled 81. And if I want to see what multiplication happened, 81 divided by 3 is 27. Also, guys, I multiplied by 3 times. Guess what that is?
27.
Which is 3 to the 3rd, or 27. I multiplied by 3 times. Next, what we're going to do is make the connection to the expression. So everybody good that if we multiply by 3 times, that's multiplying by 27.
Yes.
And it won't matter where we go in that table. If we make a jump of 3, it's always going to be times. No, a jump of 3.
Oh, a jump.
27 every time we do a jump of 3. Doesn't matter where we're at. Check it. Let's check another one on your table because I get some looks. On your table, let's go 3 cubed, which was what? 27. A jump of 3 would be 3 to the 6. What was that? 729. And what's 729 divided by 27? 27. That factor 27 is going to happen for every jump of 3, no matter where we're at on our function, because if I jump 3, that's a 3 times 3 times 3. Right? If I did a jump of 4, it'd be 3 times 3 times 3 times 3. If I did a jump of 2, it'd be 3 times 3 and so on. Are you guys seeing those jumps we're talking? So the bigger divided by the smaller. So let's look at the expression then. All right? So if I have x, my first one I'm starting with, that's just going to be 3 to the x, right? Regardless of where I'm starting, x can be anything. But the point after that we're going to test now, a jump of 3, is going to be 3 to the x plus 3. That's just saying 3 after whatever our first one is. It doesn't matter what our first one is. And when we do this division, what should we get? 27. 3 times 3 times 3. Well, let's check it out. 3 to the x plus 3 divided by 3 to the x. One factor in the exponent of x would cancel. And we're left with 3 cubed, or 27. It works even in the expression, not just with numbers from our table.
Wait, like if you're doing 3x divided by 3x.
3 to the x.
Don't both 3 to the x.
No, I still have this 3 here, right? This 3 to the x plus 3, that's a good point. I like that you're asking that. 3 to the x times 3 cubed is 3 to the x plus 3, right? So this is what's getting canceled. Just the x one.
Wait, so
I like that
if
you asked that. Yeah.
Wait,
Do you
so
see that in the warm-up now, why that's in the warm-up?
If you were to do 3 to the x times 3 to the 3rd times 3 to the 6th, then it would be 3 to the x plus 9.
You can, yeah, sure, yeah. You can add all the exponents, yep. But this is just proving that 27, not just from the table, we can do it algebraically with an expression. It doesn't matter. Any jump of 3, if we're multiplying by 3, will always be a factor of 27. If we go back to the line, we were going by 2 plus 2 each time. So let's say we made a jump of 3 with the plus 2, that'd be a jump of 6. It's just looking at the difference between lines and exponents. Y'all have a lesson summary. When you're done, homework is in the basket.